It's on. There we go. Hello, everybody. Welcome to our final day, Tandy Assembly. It's been pretty awesome to see everyone here. I've been really enjoying the show, and I hope you all have been too. I am here to talk about some of the new hardware. My name's John Elliott IV. AKA Rocket Fueled, for those of you who have seen me on Discord, and AKA IV, which was a moniker I picked up while I was at Tandy. I'm currently a software engineer contracting with Microsoft's Xbox folks for their developer support guys. Now you may be wondering who Tandy Emeritus is. Well, there's three guys that got together who used to work at Tandy who thought, you know what? We should do some stuff. So Ken Bruckner, he used to be the National Technical Support Services Director at Radio Shack. I probably said that in the wrong order. He'll get me later. Sam Sawyer, I worked with him a little bit. He was the manager of computer design at Tandy R&D. I think of him as kind of the father of the Model 2. He also, though, later was the director of computer product engineering at Radio Shack. That was, one of the second hats that he wore while he was still at Tandy. When I was at Tandy, I was a senior systems software engineer, and later in my career, I started in doing testing for operating systems and things like that, and then worked my way up into being the final system architect for Xenix. So I was the main kernel architect. I worked closely with Frank Durda IV. Frank handled pretty much all the Z80 code. He was literally a Z80 wizard. We were amazed at what he was able to squeeze out of the processor. I wrote a bunch of drivers. I don't even remember what all I wrote in Xenix. Towards the last, I would say, 2 releases, I was the main 68K guy. If there was anything that needed done on the 68K side, especially if it was in the kernel, I was the guy. After Tandy, I ended up at the Santa Cruz operation. I also worked on Xenix there. That, I was pretty happy when I got that job. It was like my dream Unix job, yay. So now for our little video demonstration. I love this, and I beg Ken, please let me put it in my talk.
If you were around for the 70s and 80s, you may remember the Wolf brand chili commercials where the crusty old guy is asking you how long it's been since you had a nice steaming bowl of Wolf brand chili. Well, I could paraphrase that and do something here like, how long has it been since you had a nice new gadget for your big Tandy? Well, that's too long. And it has been too long.
And it has been too long. And so we're like, you know what? We should do something. So we did. We put together, and by we I mean mainly Ken and Sam, put together a nice 8 megabyte board, which most of you have come by the table and seen. Some were kind enough to order some, but yeah, we put together a 8 megabyte board, a new 3-bit MMU. I'll get into a little bit later in the talk why you might want a new MMU if either you've already got a Tandy or a clone, or you don't have one, and what that means really. We also did some new software, and by we I mean mainly me, but I had a lot of help and support from the guys because at the time when we were all working on this, I had no actual working hardware. So I would do stuff in the emulator and send it to, you know, Ken or Sam, and they'd be like, "Oh yeah, it works." You know, I was like, "Oh, thank God." So yeah, I did almost all of my development in TRS-80 GP. So big shout out to George and Peter because they were fully awesome while we were working on this stuff. I'll talk a little bit about a couple of accessories. You guys have come by. You've seen them. And then I have a couple of technology. Well, not a couple. Really, it's kind of a two-in-one driver, but technology previews. And basically, that's stuff that we wanted to have ready for TA, but just didn't quite get the stuff done. But there's enough functionality there that I can demo it, and you know, Lord willing, I don't wipe my hard drive image. So yeah. So yeah, we have a new 8 megabyte memory card. Some have asked me, okay, well, what's the deal with the why? What 7.5, 8? Which is it? And, there's an architectural limitation in the Tandy 68000 CPU card, and that's basically that the memory map has to end at 7.5 megabytes because memory mapped I/O ports start at that address. So although the card, the chip that we're using really is full 8 megabytes, there's half a megabyte we couldn't use because the CPU card literally can't address it. So it's one full slot wide. So those of you with the card rails in, it'll slide nicely in and stay in there and won't wiggle around. It's only half deep. The fact that we use a slot means you don't need any power jumpers or anything on the board. So it's pulling power directly from the Z80 bus. One thing you do need to do though is it includes a replacement gal for the burst PAL that's on the CPU card. In order to get our memory card to work, we did have to rework the burst PAL a little bit because of some of the SRAM timing and things. I don't remember exactly what all that we had to fix in there because that was mainly Ken and Sam, but I do know it's required and it's not backwards compatible with the Tandy legacy cards. But it's a socketed part, so if you do want to go back and do some testing or whatever with legacy cards, you can just swap the part back. It's got a little header on it. If you want to, put a header in, I should say, and get at some of the signals on the Z80 bus, you can drop some pins in there and, hang your logic analyzer and do whatever you need to do. It's kind of handy. Okay, so what's an MMU and why do I need a new one? Well, an MMU is a memory address management device. It takes addresses from the CPU and may or may not modify them on their way to the bus to talk to the actual memory. And the one in the Tandy CPU card is super simple. Basically, it says, do nothing unless we're in user mode, in which case it may do some math on the address before it hits the 68K memory. So the basic job, the why is this even there, is that it protects the operating system from user programs, and it protects user programs from each other. So it's a multi-user security thing. So the 101 on how they work is when the kernel sets up a user process to get it ready to run, it tells the MMU, oh, okay, this guy runs at a certain location in user memory. And then when the OS actually launches the user process, then the MMU sees, oh, okay, I'm running in user mode. I better add to the address that I've been handed. And then it tells the memory, no, the kernel didn't really access 0. It's accessing this address. User program thinks it's running at 0, but because of the math that the MMU did for you, it's actually staying in its nice little corner of the memory that it was assigned. Now, the problem is the Tandy stock CPU only has an 8-bit adder in its memory, and because the MMU page size is 4K, you're limited to 1 megabyte of memory. So in a stock CPU, the MMU can only address 1 megabyte. In other words, it can only place user programs in that first megabyte. The CPU obviously can see any and all memory that you put there in supervisor mode, but the MMU can't add that high. It doesn't have enough bits in its brain. So the reason why you want an upgrade for your MMU is you just bought this shiny new 8 megabyte memory card, and wow, it'd be nice to use it all. So that's why we have our MMU card. Ta-da! Introducing the MMU3. So the MMU3 we designed to, and again by we mostly Ken, to have the nice retro look. It looks similar just visually to the Tandy MMU, and the really nice part is he designed it so that if you already have a Tandy MMU, you just pull out the Tandy and you drop this one in and you're good to go. No mods, no any additional parts. Like the XMMU, it allows you to use all of the available memory that you could conceivably address with a Tandy CPU card. And you don't have any swapping penalties or anything like that when you use, like when you use RAM swap to try and get some usage out of that extra memory that the MMU can't address. An advantage of our MMU is it works on all Tandy CPU cards, 6 megahertz long and short, and the 8 megahertz. Similar in size, you don't have any, footprint or, oh, oops, I can't quite get this to slide in anymore. That would have been bad. So, yeah, it's a fun little gadget. So, onto our software. We realized that having a new giant 68K memory card would mean that we're going to need some updated memory diagnostics. A lot of the older diagnostics assume the world ends at 1 megabyte, which is obviously wasn't even true back in Tandy's day, but nobody bothered to update the diagnostic programs. Fortunately, we had source for some of them. So I sat down and took the old Premem 68 program and modified it to be interactive, have better memory diagnostics for when you have a bad memory board. For example, it gives you an XOR of the expected and the bad, so you can see the bits that went wrong, if you will. You can fill and dump 68K memory. And obviously, most importantly, you can see and test memory past the 1 megabyte boundary. One thing we did add is the old test would do a quick memory check and then, oh, you don't have any 68K memory, and it would just exit, which is bad because if you have a broken memory board, that might be, you still might want to try and test to see what it can get at out there. So we added the ability to where if it doesn't think there's a memory card, it'll ask you. It's like, I didn't find any memory. Do you want to just test the first 256K and see what you get? So that's handy. And this time we have a user's manual. So we describe what all the options do and everything. So now we come to the fun demo. Live demo of the memory tester, anyone? Let's go. I can keep the cloth on the table here. All right. obviously this will be in an emulator, and you know, we won't actually find any memory problems, or if we do, that'll be interesting. Come on, man. There we go. All right, so when I was first fiddling with adding the whole menu system, I just added this first one because I thought it would be interesting to, I don't know, if you're fiddling with jumpers on the card or whatever and you want to see if that changed anything, you can have it recheck, okay, how big do you think the memory is now? Can you hear me now? And I was also testing the menu system itself. Do we get back to the top? You know, sometimes it would exit to Tristas and you're like, wait, what? So there's a lot of interactive features. The original Mmu 68 would typically just go quiet and sit there and you'd wonder, did it lock up? Did it crash? What's it doing? So we made it a little more interactive. You can select how many passes you want. And this is an interesting feature that we added. If you have a bad spot in memory and you're trying to scope it or put your logic analyzer on it, this was specifically something Ken asked for. He said, can you make it stop and just pound on the bad spot so I can watch it on the scope? And I was like, oh yeah, that would be easy. So now it asks you, do you want to do that? And I'll say no because I'm not expecting it to fail. Now here you see some of the interactive, you know, the old Mmu 68 would just sit there with a blinking cursor and you'd have no idea what it was doing. But now you know that, you know, the memory test hasn't even started yet. We're filling memory. And, you know, in 1 megabyte, the delays weren't so bad. But now that there's 8 times that, you know, it's nice to be able to see, oh, okay, it's working. It hasn't locked up. It's still, you know, working on the testing. The actual verification part is still quiet, but at this point you still know, all right, we haven't even started testing yet, right? It didn't lock up, it's just working on filling all the memory. So I'm going to let it fill the memory for a bit. Later I still don't like it when the test goes quiet. You're like, well, okay, presumably no news is good news, but it'd be nice to see something like this as it's testing as well, to let you know, yes, it's proceeding, nothing's locked up, you know, no bus problems, it's, you know, it's still doing its thing. So now we know it's verifying and it's just going to be quiet until it's done. So one of the features that I added that didn't used to be there, before you used to have to just reset the machine, but if you hit Control K at any point, you'll see it say break and it'll tell you the status of everything that it's done up until that point. If everything was okay, you get the message like you see there. It's like, well, everything I looked at before you told me to stop was fine. So now let's dump some memory. So this is all in hex, as well as how much memory you tell it to dump is in hex. You can press pause at any time during the output of the hex dump, and you're looking at 68K memory to see what's there, or wait, why is this all FF, you know, or whatever, right? It's got a similar fill feature, and it fills memory with a rotating pattern of 1 to FF, and it deliberately emits 0 so that it doesn't line up on address boundaries. It'll sit there and, you know, wrap around because it's 255, not 256. So again, you just put in a 68K address in hex, and you tell it, you know, how many bytes. So we'll tell it to just do 64, and this value is suspicious because obviously it's a Z80 program, so that's as big as it can fit into its registers. But there you see it just went real quick. It filled the memory, and then later you can, you know, go look at it, maybe set up with your scope, or, you know, do whatever you want to do. So that's pretty much it. It comes with a manual. We'll have a little HFE disk image for it, and that's pretty much it for that.
John, does it report where the bad memory is?
Oh yeah, there's a really long. It's like, hey, I was at this address, I read this, you know, I wanted this, and that gives you the XOR of the two, so you can see what bits are fiddly.
John, why is the top of memory 7, 7, and 4? That's not 7, 5. What is that? 7, 7. It's a top of memory.
The top of it's a hard coded limit. The where the memory mapped I/O starts is 7800. 7800 like D0. Anyway, that's the boundary where the memory mapped I/O ports start, and that's why it's 7.5 megabytes instead of 8.
Okay, you mentioned that earlier.
Yep, and that's why the address is weird like that. Anyway, all right, we're gonna talk about the kernel for a little bit. The new kernel, its probably biggest feature is the Mmu Auto Detect. The kernel now can, if it has sufficient memory, it can detect how many bits of MMU you have. You know, is it a stock MMU? Do you have maybe a Tandy or a clone? Or do you have an XMMU or MMU3? So when it boots up, you'll see a message like you're seeing on the screen here, where it says, oh, hey, you have a 10-bit MMU. You have, you know, this much memory total. Now, the kernel is smart enough to go, well, all right, if you only have 10 bits of MMU, I know that I can't put user programs past 4 megabytes. So then it also says, okay, well, I know you have 3.2 megabytes of, you know, free memory that's not going to end up really being used. Now you might be curious, okay, what's this 3.2? Why doesn't that add up? Well, when the kernel boots, if it sees that it has more memory than the MMU can address, it will actually shove all of its allocatable storage, things like buffers, C lists, and things, up past the MMU boundary. So normally, if you booted a Tandy MMU, the kernel would be this figure plus this figure, which means that you'd have almost 300K that, you know, we took away from user memory because that's an MMU addressable space. The 3.4 kernel actually is only 85K down low, and it moves this chunk outside the 4 megabyte window. Whoops. I was clicking too much. Hang on. Going the wrong direction. There we go. I think I hit the wheel. What was I saying? Oh, right. It moves the allocatable memory up above that 4 megabyte boundary, so that's why this is only 3.2, right? Some of you were probably doing the math going, wait, what? So the reason is we dropped this 207K outside of addressable memory, which maximizes the amount of memory available for user programs. We're not taking up all this allocatable stuff. So the kernel's smart enough to do that. Obviously, if you have an XMMU or an MMU3, it doesn't matter because the user can get to all available memory, and moving the kernel stuff around won't matter. So it does things normally when you boot up. Another thing that's fun that's in our release kernel is I added an RTC for TRS-80GP. George was very kind and humored me and added a pretend real-time clock register to TRS-80GP. which means that now you boot up and you'll notice that in this screenshot, it's like, oh yeah, I know what time it is. So you boot up and you go multi-user, you can just press enter. It already knows the time's been set from the host, which is really nice. There's a crash beep feature that we added. I think mainly that was Ken's idea, but I thought that's pretty cool. I should add that to config. So now if the kernel stops for any reason, and that could be because you asked it to or because it crashed, it will beep. You have to turn that on, otherwise it might be annoying if, But yeah, we have new and updated utilities. Obviously, the config utility, okay, just don't trip over that, needs to know about the new stuff. So, we updated that. We have an updated shutdown that has some new extra Berkeley stuff in it, like shutdown -K. Just kidding. Other things like that. We added reboot. I've wanted that one for a while. Bobby really wanted it. So I was like, you know what? It's time. Let's have an Etsy reboot. And, the 68,000 assembler, right. When I was working on trying to get the kernel, it was mainly in assembler, trying to get the auto detect stuff working, because that's down at the very lowest level of, all right, what's going on with this? Can we detect, where's the MMU going to redirect us? And while I was working on it, and especially adding debug code, I broke the assembler. And mainly it was because I wrote some just evilly long macros, and it basically blew the assembler's mind. And without an error, it would exit and just leave zeros where my assembled code was supposed to be. It took me a while to figure that one out. But anyway, I found out what was going on, and I fixed it. And I was like, well, why not? Pass the new fixed goodness along. One thing that'll be worth mentioning is that currently the new software will only be distributed with our hardware now at TA, and obviously anybody that's bought stuff will get access to this. And 30 days after Tandy assembly, we'll release everything to everyone. So now, I don't know why I have a blank slide in there. Okay, now we come to our Xenix demonstration. First thing I'm going to show is the speed up. So the Xenix 3.3 kernel didn't have to worry about very large memory sizes, and the startup code was never really optimized. It had the slowest possible memory sizing code and memory initialization code. It basically, did it one long word at a time in loops. So this, keep hitting the wrong button. This is what it looks like when you start up 3.3 with one of our large memory cards. So you press enter, and you wait, and you wait, and you wait. And should I go get coffee? Did it crash? Is it ever coming back? And after a suitably long evil time while Xenix evilly chuckles to itself, it'll finally boot up and, oh yeah, I found all your memory. What? So that's 3.3 booting. So now if I can type. Oh, no, wait. Reboot does need to know what kernel you're booted on because it's probing an address inside the kernel. So that's just something to keep in your back pocket when you start using and enjoying Reboot. So now we're going to boot the new kernel, Xenix 3.4. And this is how long it takes to find all of memory and initialize it. Very much faster. And you can see here, it booted up. It's like, oh, hey, I've got all the bits. I don't have to move anything. I'm good to go. So the next thing we'll demo here, I need to exit out of this this emulator. We're gonna show you what the real-time clock looks like in TRS-80GP. So here I'm not going to hit, you'll notice it's set up for auto boot, but I'm not going to do that just so I can show you the real-time clock. Otherwise the screen will flash by and you're like, wait, what did it say? So here you can see it knew what time it was. If I go ahead and hit Control D here, you'll see that it comes up, and how about that? It knows what time it is. It's exactly the same as what the host was set to. I can just hit enter and I'm good to go. Now, something that the sharp-eyed among you may have noticed is that this emulator is running in turbo mode, which normally in TRS-80GP causes your clock to drift fast because the Z80 emulation is also running at an accelerated rate. But with my real-time clock driver, the registers that George gave me allow me to know the actual passage of time, which means that with this driver loaded, it actually only ticks the Xenix clock if a real second has passed. And that's true even if you turn on haste mode, which is the, you know, the ridiculous speed, or plaid maybe even. So let's do this. So have a little test. So I'm going to run this little. Oh, I was supposed to clear the screen before. Oops. All right. So here we're running in turbo mode, and you can see it's pretty much in lockstep with the system clock over here. And that will remain true. It'll run out of true when I pull up menus like this. But even running in haste mode, you'll see it doesn't accelerate appropriately. And I just found this to be just wonderful, because when you're compiling the kernel or doing any kind of big build projects, you really want your file timestamps to stay accurate, because later if you reboot and come back and you got file times in the future, make doesn't work so well. It doesn't cope. And having this feature was just awesome. You can stay in turbo mode, build all your stuff fast, and all your timestamps stay accurate. So I'm just super grateful to George for putting this in here, just even for emulation only. Obviously, I'd like to see this in real hardware as well, although, you know, real hardware doesn't have a turbo button. But, you know, being able to boot up and just like hit F1 and let Xenix boot itself up and already know the correct time is a wonderful thing. So, oh, I suppose I should turn haste mode off because it's hard to type. Let's go back to just turbo. So those are the few things. I'll show you what the new stuff in Shutdown looks like before I bring the system down. So you'll notice there's a couple of extra options there now that it can handle. -Q is very nice. It says don't bother telling the users there aren't any. So we're just going to shut down quick and halt the system. No muss, no fuss. All right, let's see, what's next? Oh, that's not it. Oh, our accessories, yeah. Let's talk about that just for a little bit. So, most of you have probably already seen these. We're throwing in a couple of accessories that we've been working on. Ken came up with this one. Diagnostic Spacer is wonderful on your knuckles. It allows you to put space between Z80 boards without breaking the interrupt chain in your big Tandys. And anyone that's tried to pull cards out of a Model 16 or 16B can appreciate when I say it really does help your knuckles. It's got similar spacer on here that you could solder headers to. If there's stuff on the Z80 bus that you'd like to be able to get at, go hang your probes or your logic analyzer clipped on there and get at whatever Z80 bus signals you might need to look at. Pretty much everybody here has seen our keyboard adapter. It's one of the favorite projects that I've worked on. It really was fun having something that combined some software and hardware and something that was like in my ability of electronic things that can be built. But it lets you hook a modern USB keyboard to a big Tandy. And it'll do any of the models, 2, 16, 16B, and 6000. Although the B and the 6000, they need a DIN cable, right? Because you got to go, you're going from female to female. So we have those. It supports macros. If you pull out the little micro SD card that's in the side there, there's a file on there that you can edit, and I forget which jumper it is. One of these jumpers enables the macro file, and it'll read it and go, oh, okay, when he says Alt-7, I'm supposed to send this, blob of text. Some find it handy for, like if you're missing keys on your keyboard, you might want to, like, I don't know, you could map certain keys to like maybe volume up or down, or just whatever you want to do. Sometimes there's keys that are missing that you can take keys that are available and map them. So like, oh yeah, I don't have a break key on my keyboard. Well, that might be nice for Xenix. So you make a mapping that you can use with the keys that you do have on your USB keyboard. The thing that's really nice about it is its default Alt key map to the virtual console switching in Xenix. So what that means is, although you can run this in one of these jumpers, one of the jumpers selects if you're a Model 16 keyboard or you're emulating a 2000, 1000 keyboard, like Bobby's got set up back on his, the white keyboards. Because the white keyboards are what we originally used to be able to switch the virtual consoles. With this gadget, you don't have to run it in Model 2000 mode because it's got the macros built in, which means that you don't have to swap keyboards. Like if you have to boot Tristos to run a diagnostic or something, you just, leave it the same and it just all works. So it's pretty nice. Seem to have lost my mouse. There we go. Okay, now we've come to our technology previews. These are some things that we didn't quite have time to get done for Tandy assembly. So, I'm going to boot a slightly different kernel here, which will also serve as a teaser. Okay, you'll notice this looks like more or less a normal Xenix 3.4 boot up. I'm going to go into system maintenance mode here and run the CFG command. And you'll notice some interesting new items. So down at the bottom there, you see there's RAM disk and RAM swap now. This was the stuff that we wanted to include in 3.4, but just didn't quite get the work done beforehand. I'm going to give a demo of the RAM disk part of this. It's more or less working. So here's what the new usage looks like. You can enable RAM swap, and RAM swap is just auto or off. And the reason is, now that Xenix knows where the extra memory is, RAM swap, it's like, oh, okay, I'm being told where the extra memory is and where I need to go to do the RAM swap. So if you just turn that on by itself, the way it'll work is it will just allocate whatever extra memory is left over, and that's after config is grabbed whatever chunk of that is to move its buffers out of the way to maximize user MMU addressable space. But if you also tell RAM disk to grab some disk, it'll grab it first, and then RAM disk or the RAM swap gets whatever's left over. Or you can just tell RAM disk to grab it all, and that's, I think, what we'll do here. So we're going to set it for auto RAM disk, and what that means is RAM disk will just grab anything that's extra available, and then we'll go ahead and reboot. So now when we boot, you'll see a new driver pop up. Huzzah! RAM disk driver said, oh, I was told to do something. Hey, I've got extra memory. Oh, I'm supposed to give it all to the disk. So it did. So let's play with it a little bit. So the RAM disk driver said it was given 3376K of memory, but when you run make file system, it wants blocks. So 3376 times 2 to get us to 512 byte blocks. There we go. So make our file system out there. Ooh, hey, your RAM's got data in it. Yeah, go ahead. So you notice that was pretty quick, but you know, because RAM disk, so. And it's, you know, going to be pretty boring at this point. So let's fill it up with something. And you notice it goes at a pretty rapid clip. Now, admittedly, I am running turbo here because I don't like waiting. But, you know, we're if we were writing even to a, floppy emulator or a DRAM or something like that, it wouldn't be quite this fast. We're just literally sticking the data directly into 68K memory, so nothing, no Z80 involved, nothing. It's just we're going from here to there in 68,000's head. We'll let it run for a bit and then go look and see how much of the space we grabbed. All the obviously normal utilities work because Xenix thinks it's talking to a disk drive. So, you type DF and it's go, oh yeah, you use some space there. And the file's out there. And it apparently has all its marbles, so. Now, obviously, when you shut down, your data's going bye-bye, so, that's always something to keep in mind with RAM drives. But, we've had those around for quite a long time in Linux. Linux does this all the time. That's default for /temp. Quite a few other of the, I think vartemp is also RAM file system. But anyway, while the system is up, you do all the normal stuff that you would normally do, and things work well. All right. I'm going to go ahead and turn this back off. So setting RAM disk to 0 is what turns it off. You're telling it, yeah, I don't want to allocate anything. One interesting feature that it will be allowed, will be able to do once we're done with it. I think I actually have the code written, but haven't tested it yet. Oh. The blocks that you specify, if you specify a value under 100, what that means is that's a percentage of the extra RAM to grab. So let's say, well, you know what, I want a RAM disk, but I also want to do a little bit of RAM swap. You can set the RAM disk to 50, and since that's under 100, the kernel will go, oh, he wants, a percentage of the available space. So it takes that number and makes that a percentage. If it's 100 to whatever the maximum, extra size that it could be, then it takes that just as an exact number of blocks to dedicate to the RAM disk driver. That's about it for our technology demo. Anybody have any questions about the demo? Yes, sir.
The TRS-80 GP clock, is that simulation in the port space or on the 16,000 site?
Oh, you're asking about the real-time clock register. That's in 68K memory space. He just grabbed an unused chunk of memory where I told him, and we kind of hashed out how it should work, and then, I wrote the driver, and I was like, holy crap, this is nice. So, yeah, when there's a command line option. I'm sure it'll appear in a future. Obviously, I have a custom TRS-80 GP that George very kindly threw this feature in it, but you know, I'm not ever letting it go ever again. You can't have it. I'm never upgrading until this comes out in the release TRS-80 GP. It's wonderful.
I'm assuming that hardware support is coming for that?
Not for this, no.
It's just not there.
It's something that we threw together just because I was curious about, like, okay, if we did have an actual hardware RTC, how would that work? And I was just kind of noodling this around in my head, and I was like, well, we can make it super easy if we just make up a hypothetical clock that gives you Unix time in a register, and then have a millisecond register. I mean, that's about as simple as you could make one. And George was like, oh yeah, I can do that easy. I'm like, really? Ooh. So we did. That was all I had for what I needed to talk about. Were there any other questions or things people were curious about? Anyone? Bueller?
I just have a comment.
Sure.
I think it's amazing how far the Xenix community has come in just a few years from, you know, if you wanting to barely be able to run Xenix 3.2, no known MMUs in existence. So now we have the original kernel architect.
Jeez. Sorry, guys.
Original kernel architect is now creating new versions of the Tandy Xenix kernel, which blows my mind. And thank you.
It was fun. It really, really was. It'd been so long, like 35 years or something since, yeah. Anyone else? Questions, comments, rude remarks? Yes, sir.
Like can you sketch out, like, if you have a Model 2 that works, what else do you have to add to it to get to the point that you could actually use this stuff you've created?
At minimum, 3 things: upgraded power supply,
Yep,
68,000 CPU board, 68,000 memory board.
got it. Then you could start adding.
Well, then, you know, if you don't have a hard drive, obviously you're going to want that. Xenix doesn't, I mean, technically you can boot Xenix on a floppy, but there's not a whole lot of fun to be had running on a floppy. Anything else? Well, thank you for coming, everybody.